Hello everyone, welcome to my new video in the Mathematics Essentials series. I figured since I've talked so much about the sine rule and the cosine rule, I should do some examples. So let's get to it. Consider the triangle that I've provided here with a diagram. Okay, and here we've labeled each of the angles and we are given each of the side lengths. Okay, so this side here would be lowercase b, this side here is lowercase a, and this side here is lowercase c, and we know what all of them are. Okay, and suppose we are asked to find the angle C. Okay, well, since we don't know any of the angles, it wouldn't make sense to apply the sine rule, so we will apply the cosine rule. And since we are asked to find the angle C, we would write the cosine rule like this. C squared equals A squared plus B squared minus 2AC times the cosine of the angle C. Now, you can make all of your substitutions into this formula, or if you are in an exam and you are allowed to use a scientific calculator, which you would be if you had a problem like this on an exam, okay, you could just do this. Okay, just get everything that you would know onto one side. Okay, so we would have C squared minus A squared minus B squared plus, nope, that's everything that we could get onto one side, equals negative 2AC times the cosine of C. In fact, we know that we can just divide by negative 2AC. So we would have this on the left-hand side, negative 2AC, okay, equals the cosine of C. Okay, then you would substitute everything that you know into the left-hand side, not even simplify, and take the arc cosine of both sides. So doing that, we would isolate C, and I'll just write on the left-hand side, and we would have C equals the arc cosine of, let's substitute everything in now. Okay, C squared is 4 squared. Okay, A is 5. Whoops. We have minus. A is 5, so A squared is 5 squared. Minus B squared. Well, B is 7, so this is minus 7 squared. And it's all divided by negative 2 times A, which is 5. Okay, times C, which is 4. Okay, so this here is what you would punch into your scientific calculator. And if we were to simplify all of this, just doing the arithmetic, you would get 29 over 35. Okay. Now, I'm going to do some more examples with this triangle, but we should just note here that since we know all three side lengths, we could find, we could just do exactly what we've done to find the angles A and B. So we could find this angle and that angle. In fact, once we've found one of the other angles, just subtract them both from 180 degrees or pi radians if you're working in radians, and that would get you the third angle. So you'd really only need to apply the cosine rule one more time to one of the other angles, and then you would know what the third angle is by subtracting the two known angles from 180 degrees or pi radians. Okay, but I'm not going to do that because you'd just be seeing an example of the cosine rule repeated for different values. So what I will do is I will suppose that we are asked to find A, and I will use the sine rule. And just to give you an example of the sine rule in use, we would write the sine rule like this. Okay, so the sine of, come on, surface pen, the sine of A over the side length A equals, well, we know one of the other angles now, which is C. We only know one of them. By the way, an approximation for C, so I'll just move all of this down, okay? Because if you want an exact answer, okay, well, what I've done would be the exact answer, okay? There's no real other way you could write it without sort of rounding up. Okay, so you would have C is approximately equal to 34.05. That's rounding up to 2 decimal places. 34.05, and that's in degrees. Okay, so given that we know one of the angles now, we would use this equation in the sine rule. Sine A over side length A is equal to sine of the angle C over the side length C, and we could substitute everything in now, or work with the arbitrary expression first to isolate what we want to find. So we would multiply both sides by a. We would have a over c times the sine of c. Okay, and then we could take the arcsine of both sides to isolate a, and then substitute in all our values. Okay, I'm just going to substitute in the known values now. So the sine of a equals, well, the side length a, let's go back up to our triangle. Okay, it was 5, and the side length c is 4. Okay, so this actually would be sine of a equal to a over c, so that would be 5 over 4. Yes, 5 over 4 times the sine of c. Now, you should not substitute this in for c because that's an approximation for the angle c. Okay, so if you substitute that in, you would lose accuracy. In fact, what we should substitute into our equation is this for c, the arc cosine of 29 over 35. Okay, so let's do that. Okay, the sine of a equals 5 over 4 times the sine, the sine of the arc cosine, or the inverse cosine function, the arc cosine of 29 over 35, 29 over 35, okay? And then take the arc sine of both sides. So a would be equal to 5 over 4, the arc sine of the entire right-hand side in the previous line. So the arc sine of 5 over 4, okay, times the sine of the arc cosine, the inverse cosine function of 29 over 35. So if this pen is being buggy. Okay. Now, if you were to substitute all of this into your scientific calculator, wanting an approximate value for a, you get that a is approximately equal to 44.42 degrees. Okay. Now, I want to do another example with the sine rule, okay? Even though I avoided doing another example with the cosine rule, just so, just because it's repeating the same thing but substituting in different values, I think it will be good to do another example with the sine rule, and you'll see why. Okay, let's suppose we want to find, B. We want to find the angle B. Okay, we could use the cosine rule, but let's suppose we wanted to use the sine rule, and perhaps we haven't found the angle A yet. Let's suppose we hadn't done what we've just done, and we do this. Okay, we write the sine of A over the side length A, the sine of B over the side length B equals, well, we had found the angle C, okay? So we would know how to find the sine of C, and given that we have all three side lengths, we would know what the side length C is. Okay, then multiplying both sides by B, we would have that the sine of B is equal to B over C times the sine of C. Okay, and then we would take the arc sine of both sides to isolate B. Okay, let's make some substitutions now. Okay, we would have that the sine of B is equal to, well, we know what the side lengths B and C are because we know what all three side lengths are. So if we look at the triangle we were given, okay, B is 7 and C is 4. Okay, so B over C is 7 over 4. Okay, times the sine of C. Well, we found C earlier. Okay, that was the arc cosine of 29 over 5. Okay, the sine of the arc cosine of 29 over 35. All right, and then we would take the arc sine of both sides. Okay, so B would be equal to 7. Sorry, I've got to take the arc sine of both sides. So the arc sine of this entire right-hand side in the previous line, 7 over 4, times the sine of the arc cosine of 29 over 35. Okay? Now, if you were to punch this in to a scientific calculator, you would actually get that B is approximately equal to 78.46 degrees, rounded to 2 decimal places. And it turns out this isn't actually the angle we are looking for. And let's see why this is the case. Okay, we've found the angle C and the angle A. All right. Now, if you subtract the angle C from and the angle A from 180 degrees, so let's take a look at this. 180 minus A minus B, okay, sorry, minus C. This should give us the angle C. Sorry, 180 minus A minus C should give us the angle B. Okay, and I'm just going to use the approximate values right now because I just want an idea of what the angle B should be. Okay, so let's use the approximations. This is approximately equal to 180 minus, our approximation for A was 44.42 degrees. 44.42 degrees minus our approximation for C, and our approximation for C was 34.05 degrees. Okay, and this, if you were to work that out, is about 101, okay, because these are approximations, so it would be 101.54 or 53, okay? So let's just say 101.54. Now you notice I have written an equal sign here rather than an approximately equal sign, okay? Because even though this is an approximation, all right, what this equals is that, okay? In other words, this is not an approximation of that, okay? This is an approximation of that. Hence, the approximation, the approximately equal sign where approximation is occurring, and an equal sign where approximation is not occurring. Okay, so this here, all right, should be approximately B. All right, but it's nowhere near the B that we got. Okay, the approximation for B that we got was 78.46 degrees. And why is that? Well, finding B, okay, two known sides and an angle, right? The angle we are given is opposite one of the sides we know, and the angle we are trying to find is also opposite the other side that we know, right? It's also opposite one of the sides that we know. Okay, and this is actually the ambiguous case of the sine rule. So in order to get the B that we wanted, right, we haven't included the other value for the arc sine of B. So when we did this step, okay, as soon as we did this step, we knew that we needed two values, okay, and the other value that we need, right, is 180 degrees minus, okay, so 180 degrees, I'll write it over here, 180 degrees minus, okay, the initial value we got, and I'll use this, okay, so 180 degrees minus 7 over 4, sorry, the arc sine of 7 over 4, the arc sine of 7 over 4, okay, times the sine of the arc cosine of 29 over 35. Okay, and just give me a second to punch that into a scientific calculator. Okay, sine 7 over 4, so 180 minus the arc sine of 7 over 4 times the sine of the arc cosine of 29 over 35, putting in the right amount of brackets so that I don't mess up. Okay, so this is approximately equal to 101.54 degrees. And you can see that when we got an approximation of what B should be, okay, this is what we got. Okay, so actually our value for b, okay, given that when we take the arcsine, we really should have two solutions because this is the ambiguous case. The one that we are looking for is this one. Okay, the one that I just wrote down. Okay, so that's an example of the ambiguous case. And what's really going on here is your calculator, your scientific calculator, returned an acute angle when the angle you were looking for is an obtuse angle. So this angle here is an obtuse angle. All right, how does your calculator mess this up? Well, what your calculator doesn't know, okay, is that you're not talking about a triangle like this, okay? Okay, here's another triangle, all right? And you can see that this side length here that I'm indicating in red, it's really just the side length C that's kind of swung open as a gate and defined a new triangle like this. So this purple angle here could be B, okay? These sides have the same length, okay? And when we, excuse me, substituted our values into the sine rule to find the angle B, well, the only information we gave it was, let's take a look at what we wrote down to find B. Okay, this is what we wrote down here. Sine B over side length B equals sine of the angle C over the side length C. Okay, you can see, you can observe that this side length is 4 as well. Okay, so that is also the side length C. It has this, it's equal to the side length C. All right, and what we gave it was the side length A. No, we gave it the side length B. So you can see that whether we have this smaller triangle with B as an obtuse angle, or we took this larger triangle, right, with B as an acute angle, all right, we still are just punching into the sine rule, okay, the same side lengths, okay, and the same angle C, all right? So that's why we get that ambiguity. Now, as a final example, I'd like to do an example of using the sine rule to find one of the sides, okay? And what I'll do is I will find this one, and I will get rid of some of the clutter, okay? So I'll get rid of, oops. Okay, so this here is the angle B, and this is the side length 4. And I just wanted to show that, you know, in a big complicated expression that we're about to do, we're still just going to get something nice and simple out like 5, and we won't even need to use a calculator. Okay, so let's say we want to find A, okay, and since we're asked to find a side length, okay, it makes sense to write the side lengths in the numerators and the sines of the angles in the denominators. So we'll take A over sine A equals, probably we'll use C over the sine of C. Okay, the angle C was the first angle that we found, right? And just remember, when we found that angle, C ended up being equal to the arc cosine, of 29 over 35. Okay, that's what we found. All right, so we will work with this expression rather than the approximation so that we can maintain accuracy. And if we don't do that, we won't get the exact side length. We won't get 5. Okay, so let's just do some of the algebraic manipulation that we know we'll have to do. We'll multiply both sides by the sine of A, and on the right-hand side, we will have C times the sine of the angle A over the sine of the angle C. And now we can make some substitutions. So the side length C is 4. Okay, so A is equal to 4 times the sine of A. Okay, the sine of A over the sine of C. But what was the sine of A? Okay, if we go back to when we found the sine of A, rather than using an approximation, we will use this expression. Okay, so we will use the arcsine of 5 over 4 times the sine of the arc cosine of 29 over 35. And this example is going to work out really neat. Okay, so heading back up to a current example. So we have 4 times the sine of A, okay, which is, an A is the arc sine of 5/4 times the sine of the arc cosine. Okay, so this expression might be starting to look complicated and scary, of 29/35. And all of that is divided by the sine of C. The sine of, and I've written what C is up here. It's the arc cosine of 29/35. And now everything collapses and simplifies, okay? Because, all right, you might recognize this here also as the sine of C. The sine of the arc cosine of 29/35, okay? This here is the sine of C. Okay, so if we can get rid of some of this stuff, we're going to get some cancellation. We can get rid of some of this stuff, okay? So we have 4 times, well, notice here that we are taking the sine of the arc sine, okay? Sine and arc sine are inverse functions. They undo each other, all right? Which means we can just forget about that, all right? And we have 4 times 5/4, all right, times the sine of the arc cosine. Okay, we could have written this as just the sine of C, all right, the arc cosine of 29/35, all right, all divided by the sine of the arc cosine of 29/35. And we're pretty much done, but I'm going to do one more step just so you see that it really does work out nicely. Okay, since this is the same thing over the same thing, they cancel. So we are just left with 4 times this fraction, 5/4. So now the 4's cancel, and we are just left with 5. And what are we trying to find? We're trying to find the side length A. We ended up with the answer 5. And if we look at our triangle, yes, that was the side length of A, lowercase a. Okay, so that worked out quite nicely. That big, complicated expression, I mean, here, it started to look quite ugly, all right? But it turns out we didn't even need a calculator for any of that. It was all solvable by hand, okay? So don't let big, complicated-looking expressions scare you. It really might just be something that's simple and collapses quite quickly in disguise of something scary, okay? So if you enjoyed this video, feel free to give it a like or share it. If you have any questions about what I've done, post it in the comments. If you want to see more examples, just let me know in the comments. And if you'd like a notification when I upload a new video, just subscribe to my channel. Until next time, bye for now.